Software modules share information to form a complete application, but as these individual pieces connect, the dependencies between them can quickly escalate into a tangled, chaotic web. A system with an excessive number of these connections becomes highly volatile. Alter a single variable in one module, and you risk crashing an entirely different part of the system. To prevent this structural collapse, software architecture relies on a specific target: high cohesion paired with low coupling. This means maintaining strong internal relationships within a specific block of code, while ensuring external relationships between different blocks remain as weak as possible. Coupling follows a 6-level hierarchy. This spectrum ranges from practices that create destructive dependency to those that provide ideal module isolation. Moving a codebase towards the bottom of this scale ensures that modifications to one module don't cause cascading failures elsewhere. The first 3 levels of the spectrum represent the highest risk to your software. We begin with content coupling. Imagine a student reaching over, opening a classmate's private notebook, erasing an answer, and writing in a new one. The first student is directly overwriting the second student's private work. In code, content coupling occurs when one module explicitly modifies the internal, private data of another. Module A is reaching directly into the implementation of Module B. If Module B ever updates its internal structure, Module A will stop working immediately. One step down the spectrum is common coupling. This is the equivalent of a shared classroom notice board. Anyone can walk up, erase a message, and write something new. Because the board is public, it is impossible to verify who changed the information or when. You create common coupling when multiple independent modules share the same global variable. When dozens of independent functions draw lines directly to one piece of shared data, debugging becomes nearly impossible because any module could be the source of an unexpected side effect. The third type is control coupling. Think of a teacher telling a student, "If I hold up one finger, take notes. If I hold up 2 fingers, erase the board." The student's actions are entirely dictated by the teacher's specific signal. Control coupling happens when one module receives a command flag from another, and that flag explicitly dictates its internal execution flow. The receiving module loses its independence, becoming tied to the control logic of the sender. Content, common, and control coupling create a fragile architecture. By intertwining internal data and global variables, you ensure that a single change in one module will likely break the rest of the application. To build independent modules, we must minimize the information they share. The transition to better practices begins with stamp coupling. Imagine a friend asks for your phone number, and in response, you hand them your entire 500-page personal file. Stamp coupling occurs when you pass a complex data structure into a function that only uses a single minor field from that structure. You are transferring unnecessary data, which increases the dependency between those modules. Let's try to fix this. Pause the video and look at the print name function. How would you rewrite this parameter to transfer only the absolute minimum data required? The solution is data coupling. By stripping away the student structure and isolating the exact variable needed, just the name string, you sever the dependency. This makes the system easier to test because modules only communicate through strictly required data. The highest level of quality is message coupling. It operates like a food delivery app. You tap order, and the app communicates with the restaurant and the bank. You don't need to know the recipe in the kitchen or the internal database logic of the bank. In object-oriented programming, message coupling allows modules to interact purely through method requests, entirely hiding their internal algorithms. The sender simply requests an action without seeing the mechanics of the receiver. Using minimal data and message requests creates a system where underlying modules can be entirely rewritten without forcing changes on the rest of the application. To permanently remember the sequence of coupling from worst to best, use this phrase: crazy cat